AMD just announced next-gen GPU tech that seriously looks incredible. Nvidia has got to be concerned. But before I get to that, AMD crushes Nvidia in the new Call of Duty, but not so much in the new Battlefield. And Intel announced their next-gen GPU architecture. Welcome everyone to Gamer Melt. Okay, it's news time, and first up for today, we have performance numbers for both Call of Duty Black Ops 7 and Battlefield 6. And starting with the new Call of Duty, AMD's RX 9070 XT just destroyed Nvidia's 5070 Ti, which is wild because the 9070 XT usually loses to the 5070 Ti. But here, it doesn't just kind of beat it, it's not even close. As you can see right down here, this originally comes from Computer Base, and it's from the beta version of Call of Duty. So things may change from now until the release, but don't forget that it's only a month away. I'm not sure they can do enough optimization in such a short time. Either way, AMD's RX 9070 XT destroys the 5070 Ti. We're talking 155 FPS versus 203. That's a whopping 31% performance increase over the 5070 Ti. And like I said, it's usually the other way around. Now, not by 31%, but typically the 5070 Ti does win. So this absolutely does not look like just a small optimization issue or anything like that. Looks like the 9070 XT just does way better in this engine. Not only that, but you can see that the 1% lows are fairly different as well. We're talking 116 versus 145. Basically, things are not looking good for Nvidia when it comes to the new Call of Duty game. With that said, when it comes to the new Battlefield 6, things sort of turn around. I say sort of because while the 5070 Ti does beat the 9070 XT, it doesn't beat it by as much. We're talking 119 to 134 at 1080p, then at 1440p, we're talking 85 to 96. That is a bit of a difference, but once again, not as much. Then when we move down to 4K, we're talking 47.7 to 52.6. And in fact, at 4K, the 7900 XTX ultimately squeezes out a win. I think this really just shows how important the game engine is, how well that translates to performance based on the GPU architecture, as well as optimization and things like that. One GPU likely isn't going to win in every game, unless of course it's so much faster that optimization and things like that don't matter enough to make up that difference. And next up, the 9950 X3D is at its best price right now, and the 7800 X3D is over $100 off. Those are just two examples of Micro Center's fall savings event going on right now, and they sponsored today's video, so a huge thanks for that. For those who still haven't been to Micro Center, I have no clue what you're waiting on, because not only do they have some of the best prices in the industry, they're also a place you can actually go in person to get all the parts for your PC build. And I'm not talking one motherboard off in the corner or something like that. I'm talking they have rows of motherboards, tons of PC cases, loads of coolers. They even have parts for a custom water cooling loop. You can't beat it. Not to mention their knowledgeable staff that can help you with your build. And they've been building out more stores lately, with their newest location coming to Phoenix, Arizona. So don't wait any longer and check out Micro Center down in the description before these deals are gone. Next up for today, Intel just announced their next generation GPU architecture along with new gaming GPU tech. And some of it's really surprising, but I have to say that I'm not liking where this is going. So starting things off, as you can see, Intel announced Xe3, their next generation graphics architecture. But before I get too deep into the actual tech and all of that, we have to talk about how Intel is separating this new architecture. As you can see right here, Xe3 is set to be released within Panther Lake, which is of course their next gen APUs, or SoCs, I guess you could say, their laptop chips. And right next to it, you'll notice Battle Mage, which these are both separated into something called the Arc B series. Now, that's a little odd, of course, given the fact that Battle Mage is based on Xe2. And you'll also notice that there's a new Arc family but that means that Xe3 is only for Panther Lake, and unfortunately that is the case. Now, this Xe3P is for a next ARC family, which should include their Celestial discrete GPUs, but the simple fact is that Xe3 is only going in their upcoming notebook chips as the iGPU. It'll be that P Performance Xe3 that actually goes into their next generation discrete GPUs. With that said, don't go anywhere because we are going to be talking about some new technology that does affect their current gen discrete GPUs. But before I get into that, I do have to talk about this new Xe3. As you can see, it comes with the new 3rd generation Xe core, enhanced ray tracing unit, all of this good stuff. And while this is fairly interesting, the real important part is what type of performance this actually brings. And as you can see, according to them, we're talking over 50% performance increase versus Lunar Lake. And then when we're talking performance per watt, they claim an over 40% performance per watt versus Arrow Lake H. Now, the fact that they're comparing that to Arrow Lake H instead of Lunar Lake doesn't really sound all that impressive. Don't forget that Lunar Lake was the SoC that included the memory on the chip, and it ended up being very good when it came to things like performance per watt. Basically, it was great for battery life. So I do find it interesting that they're not comparing performance per watt versus Lunar Lake. Still, this does look fairly decent, but this now brings us to their new technology, XeSS3. Don't forget that XeSS is their AI technology that includes upscaling as well as frame generation. Because with this, they've announced multi-frame generation. Don't forget that multi-frame gen is what DLSS4 introduced, where they can make multiple AI-generated frames after one real frame, effectively upping the FPS, but at the cost of latency. And this is where I'm really not liking where Intel is going with this. You can see in this slide that they're saying to render less, generate more, essentially proving that Intel is moving in the same direction as Nvidia. Now, maybe this is the future of gaming, but I definitely hope not. Either way, they do go into their multi-frame gen a little bit more, and you can see that it's very, very similar to Nvidia's because for every real frame, they're able to interpolate up to 3 fake frames. Now, they do try to talk about smoothness and things like that, but unless this is significantly different from the way Nvidia does it, which I highly doubt, we do know that there definitely are some major issues when it comes to this multi-frame gen. One good thing I will say is that it's set to be supported on all of Intel's ARC discrete GPUs. Another thing that they are going to be adding an override feature where you can actually select how much frame gen 2 times, 3 times, 4 times that you want it to kind of default to in the game. So that's definitely a nice feature to have, but ultimately, like I said, I'm really not happy about this move, but let me know what you think down in the comments below. And lastly for today, AMD just announced their next-gen GPU tech set to put RX 10000 on a whole new level. I'm talking they have a brand new core, yet that's actually the least interesting part. This could see AMD completely leapfrog Nvidia in everything. The story originally comes from a new video by AMD with the company's head of senior VP and general manager of computing and graphics, Jack Hoon. So this is the leader of their whole graphics division. And in the video, he sits down with Sony's PS5 lead architect, Mark Cerny, to discuss their upcoming graphics technology. Specifically, they unveiled 3 new technologies: neural arrays, radiance cores, and universal compression. Now, right off the bat, radiance cores are new, dedicated hardware made specifically for ray traversal, which is a part of the ray tracing pipeline that's very computationally expensive. So obviously, this is designed to help with real-time ray tracing and path tracing. This is very similar to Nvidia's RT cores, so in a way it's AMD playing catch up, but given how good their 9000 series already is in ray tracing, it could be a huge win for next gen. But like I said, that's actually the least interesting part here. Things start to get fun when we discuss neural arrays. From what AMD described, this is essentially an interconnect like their Infinity Fabric that connects every compute unit together to allow them to talk to one another directly without needing to use cache. Now, AMD describes this in terms of AI, meaning it would be used more for upscaling and things like that, but according to Tom's Hardware, the neural arrays connect the entirety of the compute unit together instead of just the AI portions, so maybe it could help in other ways as well. Finally, we have universal compression, and this one is wild because according to AMD, it's a new system that evaluates and compresses all available data within the GPU to dramatically reduce memory bandwidth usage. This is huge because it's completely different from what AMD, Sony, or Nvidia currently do, which mostly is just compress things like textures and render targets. This one, on the other hand, would compress all GPU data types, which, as they state, would deliver new levels of performance with greater efficiency. Basically, these new technologies will push AMD ahead of where they are now. And while this video was shared as more of a console perspective, because this is technology coming out of Project Amethyst, the joint venture between AMD and Sony, it's almost certainly set to come in future discrete AMD GPUs as well. According to Tom's Hardware, Jack Hoon confirmed that universal compression will be coming to future AMD SoCs and GPUs. But given the fact that Mark Cerny has also helped with RDNA 5, it's almost certain that these will come in their next-gen gaming GPUs, given they would be based on RDNA 5 or UDNA, whatever you want to call it. And with this new tech, AMD may finally be able to not only catch up to Nvidia, but even potentially beat them.